So for this problem, we have an input of letters or a string that's up to 9 characters. And he tells us that you should use insertion sort. Technically, I don't think you have to, but usually whatever he puts on the top is what you should use. So it takes 9 characters, and then it's going to return a list of the longest words that could be made with those 9 characters. And it needs to return it in alphabetical order. So if you're not returning in alphabetical order, then it's not going to give you the points. Okay, so can someone tell me the example he gave? Like, it's something like that. Let me check. Or if anyone knows. Okay, yeah, so it's N, J, W, H, O, A, R, G, and then U. And then it returns the longest words, jargon, and powering. So make sure that you print all of the words that are the longest word length, not just one word. Or don't stop your code when you reach like the longest word. Okay. So does everyone understand like what we're looking for? Just put yes in the chat if you understand just the problem. Okay. So he gives us some starter code. Well, the first thing we need to do is add our words to an array list from words.text. So he gives us a text file and you can't like iterate through the text file. So take the text file and put it into an array list. And then the next thing is he gives some starters code, which is C state and something else like deck or something. All subsets deck. So you guys want to be utilizing this because it's gonna get rid of like half the word. So this code right here will give you all the subset of a particular word. So or whatever particular input. So for example, if the input is PTA, right? The all subsets deck, the thing that he already gave you guys is gonna give all the possible subsets. So P, T, A, T, A, P, T, P, A, and PTA. So that's all the combinations of these 3 letters. Just the P and the T and the A would be if it's just one, and then they have subsets where there's 2, and then the one where there's 3. So if you're looking at the longest, if you want to find the longest words, which one of these subsets would we look at first? So ETA, yeah, exactly. So you want to start off with the longest subset and move backwards. So the first thing you want to do is order the subsets from longest to shortest. That way, if we find a word that is with PTA, we don't need to continue to PA, PT, TA, any of these, because we already found the longest word. So if we've already found a word of length 3, then why would we continue to words of length 2? So these subsets, we can unscramble them to see what words we can make out of them. Okay. So we're going to start with the PTA, right? How can we go through words.txt and see if PTA is equal to one of the words? Does anyone have any ideas?
To get the longest word, we
Mm-hmm.
can to get the longest word we can use string dot length
Um,
using like string match list.
I think you're saying like you can skip over words that are not the same length as the subset, right?
Yeah,
Okay. So yeah, in words and words.txt, um, yeah, in words.txt, you can skip over words that when you're looking at PTA, you don't need to look at words that are length of 2, length of 1, length of 4. You only need to look at words that are the same length. Because how could PTA be equivalent to like the word after, be equivalent to a word that's longer? So that's one thing you can do is only look at words that are the same length. Because remember, the main problem with this homework assignment is about time and saving time. Okay, so that's one thing you can do. Another thing you can do is, okay, we obviously know PTA, that makes the words tap, right? And that makes the words pat. Like just thinking logically, you can make those two words. So if I'm going through words.txt and I'm comparing PTA to TAP, that's gonna return false, right? They're not equivalent. But we know that we're rearranging the word, so we want it to be equivalent. So how can we compare these two and somehow return true? Does anyone have any ideas? Compare characters? Mm-hmm. So I guess what Moksha is saying is you can look at, okay, this has a P and this has a P. And this has a T and this has a T. And this has an A and this has an A. Use the word pair class from last line. I don't know. I didn't look at that, so I don't know exactly what that is. What does the word pair class do? Sort then compare, yeah. Well, I was gonna do what Rushi said. I'm not sure what the word pair class is. Maybe you could use that. But yeah, Rushi was saying to sort and then compare. So basically, if you look at PTA, right? Let's put PTA in alphabetical order. What does PTA put in alphabetical order? Mm-hmm. APT. And then if we do the same thing to our word, let's say we're going through words.txt and we get to tap. Well, tap, if we put that in alphabetical order, it's also going to be APT, right? So then now if we compare these two, we will return true. Okay? So how are we getting it into alphabetical order? So basically we're sorting, right? So if we create a function that sorts it into alphabetical order, we can use insertion sort. Now, insertion sort is not the fastest sorting method by any means, but it works well for smaller things that need to be sorted. So that's why, since our word only goes up to 9 letters, it's fine to use insertion sort. Okay, so we can use insertion sort to change the PTA into APT. So now when we go through words.txt, anytime we compare these two and they equal the same thing, then we can add that to our answers. So we already said this. We said pat, and then also apt would be one, and tap. So from doing that, we got 3 words. Now, are we gonna now we did the first subset. That was only this one. Should we continue to the next one? All right. Yeah, Jason said not really. Yeah, there's no need to go to this subset because we already have answers with 3. Now, let me ask you guys a question, right? Let's say PTA, there's no words in PTA. So we go to PA, right? And we find 2 words. Should we go to PT then? Exactly. So we need to find all words that are of the longest length. It could still be the same length, yeah. So once we find a word, we need to go to all other subsets that are the same length as that word. But we wouldn't need to go to A, T, or P still. Okay. So let's go through another example. So if we have DG00, and we're already saying that we already went through words.txt and we made the array list already. So now we only need to look at, we need to create all of our subsets. So D, G, O, O, I think, oh wait, hold on. I created the subsets in a different order. Okay, so if we started with O, O, G, D, and then let's create our subsets. We'd have O, another O, G, D. I'm just writing them all out. I'm just assuming you guys like understand. Like first we're just looking, this is a subset, this is a subset. Each thing is a subset, then these 2 are a subset. 2 are a subset, those 2 are a subset. And you don't need to worry about making this because he already made like the code that creates all the subsets. So you just need to get all of the subsets. So GD, OG, OD, OGD. I'm just writing them all out. And sometimes there's repeat subsets. You could technically like skip them or something like that. I didn't need to do that when I did this assignment, but you can. Okay, so then we created the subsets, but now we need to look at it in order from greatest to least. So I actually used insertion sort for this too to order them, but you don't have to. So order from greatest to least, that means this would be first. And then all the ones with 3. all the ones with 2. There's some more. And then the ones with 1. All right, so now we need to take our word, which was our input, which was OOGD, and put it into alphabetical order. So what would it be then? Mm-hmm. So let's go through insertion sort and how insertion sort works. So I'm sure you guys have some version of insertion sort in the slides, I think. And you just need to change it to look at, in this scenario, to look at the individual characters. But you can use the same like insertion sort for all types, just change it to be for like numbers or characters, that kind of thing. So if we started off with OOGD, the first thing you do is compare these two and say, does this one need to be switched with this one? And since they're the same, you don't need to, right? So then the next thing we would do is go to the G and compare the G with the O. And since G comes before O, they would need to switch with each other. And now we have to check G with the first element. And again, G comes before O, so that would be switched with each other. So now we check this one, we check this one and this one. And now we need to look at the last one. So we compare D and O. Do they need to be switched? Mm-hmm. Now we compare D with this O, and then it's the same D and O, so they need to be switched too. And then compare this with this. Do they need to be switched? Mm-hmm. So that's how insertion sort works. Does anyone want me to go over another example? Okay. Okay, so now that we got it in alphabetical order using our insertion sort, we can go through words that text, compare DG00 to each alphabetized word. And then from that, you're gonna get good, because good is DG00 and OO in alphabetical order. And then that would return DG00. And also remember when because this one only had one, but remember when you're printing your answers, they also need to be in alphabetical order. So, I think in the example he gave us, you can use that. For jargon and ouring or whatever, the J is before the O, so that one was printed first. So I also use another type of I also use insertion sort to alphabetize the words. Okay, so we got good for this one. And do you guys want to do another example? Okay. Yeah, so let's do OUSP as our input. So the first thing we need to do is create our subset. So do you guys, I wrote it differently in my paper, so let me just rewrite it so it's easier. So P, O, U, and S. Can you guys tell me what our subsets would be? So P, O, U, S, what else? Mm-hmm. Um, so it'd be something like that. So these are all the subsets that is automatically created by using the starter code that he gave, which is like all subsets deck or something. I'm not exactly sure. And now we want to change the order to look at this first, and then the ones with 3, and then the ones with 2, and then the ones with 1. So if we start with POUS, we're going to use insertion sort to alphabetize them. So what would this be in alphabetical order? Mm-hmm. One second. Okay. So after we get this, we need to compare it to each word in words.txt. So what word can we make with this? Anybody want to unscramble it? Yes, soup. There's also this other word, opus or something. When I ran it, I don't know what that is, but anyway. So yeah, so the last one was good, and then this one is soup. And that's pretty much it. Let's go through the insertion sort for it. So if we have POUS as our input, and we then do the insertion sort, first we're gonna look at the second one and compare it to the first one. So would we switch the P and the O? Mm-hmm. Yep, so O comes before P in the alphabet, so we would switch those. And next we have to check the third one with the second one. And we don't need to switch the P and the U. So we can continue on to the fourth index, or the third index. So we check S with the U. And do we need to switch those? Does U come before S in the alphabet? Yep, so it's already good, and then we alphabetize our word. So now we got these two answers, and you can do the same thing where instead of having a word, we can have, instead of having a letter, we can look at the word. So if we have soup and opus, we can just look at the first letter and alphabetize by that. So in this case, if we did the same insertion sort except with words, then opus would come before soup and you would switch them. And now you can print the words and have it print in alphabetical order. And then let's go over just one more thing. So let's say that we couldn't find any words. Soup doesn't exist in our language anymore. So we couldn't find any words for the 4. We have to go to the 3-letter subsets. And we don't find anything in the 3-letter subsets either. So now we find something, we don't find anything in this, and we find something here. Do we need to check PO? We do need to check PO because we need to print all words that are of the length of the longest word. So if we find a longest word that is length 2, right? Is our longest word, we need to check all subsets that have the length 2 because we might have more than one longest word. Like, anyone can think of an example? I guess, like D, G, O, and R. So the longest, this is our longest subset. But can you make any words with D, G, O, and R? I'm gonna say no, we can't. So now we have to look at the 3-letter subset. So D, G, O, and D, O, R, G, O, R, and then the 2. I'm not sure if I'm writing all of them, but I'm just writing some of them. So now we have these 2-letter subsets and our 3-letter subsets, and then D, G, O, R. So let's say these are all of our subsets. So we looked at D, G, O, R, and we couldn't find any words. So now we look at this one, and from this we can make dog, we can make God. And then, so should we continue and look at this one? Because from this we could get rod. And then we would look at this one too. I don't think you can make anything with that. So nothing. So would I look at this? At Geo? Nope. Yep, so once you find the longest word, you have to look at all subsets of that longest word. And then you can stop. And just make sure to print in alphabetical order. And use insertion sort to compare the 2 words. Does everyone understand that general process? Okay, any questions? And remember, this is all about time, is this assignment, so skip words that are not the length of the word you're looking at, and only look at the subsets. Don't go through all the subsets, stop once you get to your longest words. And yeah, that's pretty much it. I'll stop the recording, but I'm gonna stay for any questions. And I'm gonna send the Google form link. What would happen if you input a group of letters that already form a word? You're saying like if I did like dog or something? Okay. Yeah, it would do the same thing, right? It would still create all the subsets. And like this. And then dog. So when it does the longest words, it'll still look at this and it should return dog, but it would also have to return God, because that's also, if you unscramble this, that's another word you can make from those 3 letters. So it would return the word that you put in, but it should also return any other words that have those same letters and are the same length. Any other questions?